studied economics, interpreting, and translation in uni, and then somehow went from that to becoming a dental nurse for 2.5 years, before realizing that wasn't the career she wanted, and then self-teaching herself. That's how that works. You know, becoming a self-taught QA engineer and learning those coding skills. So later, under the mentorship of her other software engineers at Airtasker, she actually got the skills to become an engineer as well. In addition to Ruby, she loves Lord of the Rings, a ridiculous amount, and she loves to make fondant cakes, which is like a ridiculous skill that I have tried and failed at really badly, so I'm definitely very impressed with that. Please make Nancy very welcome.
So hi everyone, I'm Nancy, a software engineer from Airtasker. So today I'm going to walk you through our journey of performance testing with Ruby. First, I want to start with a question. So imagine one day your CEO is on Ellen show, and he or she is talking about your application, doing some public relations for your company, right? And so how many of you will be confident to say that I know whether our platform is going to survive from the huge spike of traffic? And if it doesn't, I know whether, where the breaking point would be. If you raise your hand if you know. No one? OK. Yeah, so let's move to a more realistic question. So one day your business think, we've done good enough in Australia. Let's conquer the rest of the world by expanding to 3 more countries in the next 12 months. How many of you knows whether your current infrastructure is going to support such expansion? Okay, still no. That's exactly what I was expected. And so for most of the people who don't know, well, for all of the people who don't know the answer, and who want some light to shine in the dark, this speech is for you. Yeah, so I'm going to walk you through the journey of our performance testing from design to implementation, and finally our learnings. So I want to talk about the whys. Why do we want to do performance testing? We want to find the invisible boundary lines. There's a line we knew when we cross it as the platform falls down, but we don't know exactly where it is. Every engineer works in a particular area, so they may know the limitation of that certain area, but they may not have an idea of the whole picture. And we want to understand the limitation of our current infrastructure in order to prepare for global expansion. We also want to understand how the platform behaves under extreme circumstances. Because when things get extreme, it's not necessarily a smooth degradation of performance. We tend to get really weird behaviors. And we want to be more proactive rather than reactive. Let me give you an example. So the company I'm working for, Airtasker, is a marketplace for people to outsource their everyday tasks. So 2 years ago, we had this marketing campaign, which we pay people $500 for them to play with puppies. So you can imagine how many people flooded into our platform, right? We get 1,700 bids on that one task. And not until we start to celebrate, things start to breaking down. All the alerts start to scream. And when this happened, we were at a company offsite. So people were like, put down your beer, let's go and put out the fire now. So as our business grows, right, things like this may happen even more and more often, and this will damage our brand reputation for sure. So in order to prevent something like this to happen again, we would want to be more proactive. So what's the process of performance testing? The first step will be determining performance criteria. This is where we gather enough information to ask the correct questions and also determine what types of performance testing we want to do. Also determine the criteria based on the questions and the type of testing. The second step will be to configure test environment. This is where we want to build a test environment that's simulating our production environment. and also like arrange any tools that's necessary. The third step would be plan and design. This is where we identify how the real users behaves and design the test scenarios and test cases based on those behaviors. This is also where we want to decide, hey, where should our test data coming from? It can come from the database or a CSV file you prepared, or you can just randomly generate the data in the code, right? And the fourth step will be implementing the designs. This is where we actually build the framework, hook up any monitoring tools we needed, create test cases, and also prepare the test data. The fifth step will be actually execute and monitoring the test. And finally, we want to analyze the test result and fine-tune our application based on the result, and rerun the test in order to compare the result. So let me talk about the first phase, determine the criteria. We need to know what types of performance testing exist and when to use them, because our criteria will be set based on the types. For load testing, it's just to test the system behavior under a certain anticipated load. Stress testing is to find the breaking point by hitting the most accessed transactions with an incremental number of users until the system breaks. For spike testing, this is where we analyze the system behavior when we're exposed to intensity peaks. Volume testing is to trying to increase your data set in your database so that the impact on the response time can be examined. Endurance testing is much similar to load testing, also like run with anticipated load, but with a much longer period of time so that the memory consumption can be observed. So to give you a better idea, so you can see the relationship between the testing time and the virtual users here. As you can see here, load test is just like run with a certain number of users. Endurance test is the same, but with a much longer period of time. So issues like memory leaks can be surfaced. And for stress test, it's like climbing up the stairs until you find the very top. For spec testing, as you can see, it's just testing with a sudden increased number of users, also mixed with the regular load. So speaking of stress testing, so we want to ask the correct questions, right, in order to set the criteria. When it comes to performance tests, people usually ask questions like this: what's our average response time? How much traffic can we handle? How many users can we sustain? But those questions just are not really useful. They're too generic to serve any business value. So when we ask questions like this, the response often depends on a lot of things. Like, is the user logging or not? Is there any caching or load balancing mechanisms? Is the traffic coming from Australia or outside Australia, right? It really depends. So here are some examples of more appropriate questions that can serve business value. Given a regular production traffic profile increasing at a given rate, at what point do we see unacceptable performance from key functionality? And another example would be, how much headroom does our current infrastructure have, and where are the bottlenecks? So if we just double or even triple our traffic tomorrow, can our application handle it? If our database side can handle it easily, what else can't? So to answer the above two questions, we would want to stress test our applications. We can set criteria like the error rate does not go above to 0.5% with a certain number of users, like big number of users. So yeah, speaking of stress testing, I've been stress testing my public speaking skills from like a 5 minutes demo in front of 15 people to 10 minutes engineer talks in front of 40 engineers to today's, like 400 or 500 people for 35 minutes of talk. So the question is, are we going to see me pass out on the stage due to nervousness? Yeah, let's find out the result in 30 minutes. Okay, going back to the boring question. If there's a big marketing campaign coming up, how far and how quickly can we scale to meet the demand? This is a great candidate for spec testing. We can get historical data from business in regards to how much more traffic we tend to get when a big marketing campaign comes up. Let's say we have like 300% more users than Europe, right? So we can set our criteria like the node and deployment replicas can scale within several minutes to meet the demand with 300% of our current traffic. In a nutshell, are we going to explode? So I want to talk about the test environment now. We want the test environment to be a production equivalent environment so that the testing result can be as accurate as possible. We want it to be isolated since we're going to throw like tons of traffic on it and we intentionally want to break it. So it's not a good idea if we run the test on production, right? And we may run some like end-to-end automated tests where people may doing their manual testing on your dev or stage environment. If we do performance testing on the same environment, then none of the testing result will be accurate. So how we did it, we run the same like Docker image as our production, but in a different Kubernetes cluster. And for one-on-one scaled resources, we just want to copy everything, like our production, like the configurations of our AWS instance type, or the CPU memory request for your database, just everything. We've done that by using Terraform. It is a tool for infrastructure as code. So we'll provision all of our AWS resources using Terraform. So I'm not going to go any deeper into Terraform or Kubernetes as they are kind of out of scope of this speech. We would also want the same data volume, right? So if we have a smaller data set in our testing database, then issues like slow queries won't be surfaced. So we've done that by taking a snapshot of our production database and anonymize it. Last, since if we keep the whole environment, the whole resource running all the time, it can be quite expensive. So we would want to do something that can be provisioned on demand. So we have read a bash script that allows us to easily and quickly spin the test environment up and tear it down, which I'm going to show you later. So coming to the tool selection criteria, we would want a tool that can easily simulate the production like traffic. And industry standard tools means it's well maintained and has good community support. We want it to be easy to create and maintain tests because we don't really want tools that has a big learning curve because we want everyone in my company to be able to use and to run the test. Also, keep history of the test runs are also important because we need to compare for the result from time to time. Visualize the result will definitely help us to analyze the result more easily. Also, we may want to run our performance test on a regular basis. So it's important that it can be integrated with CI tools. Also, we may need monitoring tools to gather more detailed information. So there are a lot of performance testing tools on the market now. Some of them are open source, some are not. If it's just a small scale of test, then open source tools like JMeter would be enough. But this kind of tools, open source tools, has its limitation. For example, JMeter can only generate like 400 to 800 virtual users, depending on the script. If we try to run the test on a single machine with more users, then it's going to throw an out-of-memory error. So in order to run a more appropriate, bigger scale of tests, you may want to choose one of the commercial tools. They are built on top of the open source ones, so which means they can generate much more virtual users, but running the JMeter test plans. They can also offer some more detailed good reports dashboard. So, since they're not free, you may also want to take budget into considerations. So, the winner in our case is JMeter to describing the traffic, which means generate test plans, because it has the largest user base and really good dashboard we can use. We've also chose Flat.io, I think, which is also one of our sponsors here, and because it comes in with a really good open source gem. It's called Ruby JMeter. It is a Ruby-based DSL for building JMeter test plans. So it gives us the benefits of writing and maintaining test plans in Ruby code, rather than the messy XML format. So coming to the next step, the plan and design stage. We have several best practices we want to follow. First, is ramping up users. Don't start all threads at the same time. This simply isn't realistic and can create some artificial bottlenecks in the system. Also, try not to start from a zero-load situation, because many test plans start from a base boot-up situation and slowly adding up more traffic until the desired load is reached. This is also not realistic and can give a false picture of the system load to the engineers. We want to take different clients and browsers into considerations, since not all traffic are going to come from the same type of device or browser. Also, distribute user load to simulate production traffic profile. Since not 100% of the users going to do exactly the same thing at a certain point of time, right? We may have 50% of the users logging in, the other 50% signing up. So we want to get a traffic profile, or a production traffic profile, by HTTP method and endpoints, so that we know what endpoints, or in our case, the get method, get request, to focus on. For implementing test designs, this is the implementation in Airtasker that allows our different teams to be able to use it. So I'm going to show you the script that allows to spin up the test environment. So first, if the command is up, then we just simply go to the Terraform repo and provision the resource, apply the Terraform plans from there. And then we would create our deployment by applying all the Kubernetes configurations. Same for done. We destroy our deployment first, and then tear down all of the AWS resources we provisioned by Terraform before. So the end result is just as easy as up and down. Next, I want to show you how our test data looks like. So I'm using Swagger Pet Store as example here. So we have their name, category, status, and their selfies. And in order to keep the repo dry, right, we want to create some helper method that can be used in all of the test cases. So, for example, we have set some the default host and the request header, which include the content type, JSON, and maybe also include your authentication token, and also the reports you would want to see. So how do we actually create test cases using that Ruby JMeter gem? Right, we start by simply doing test, and at the end, we create the JMX file. JMX file is basically XML file that JMeter can understand. So next, we define the how many virtual users we want, what's the ramp-up time, and also how long we want the test run. Next, we want to define the HTTP method and also the endpoint. Also, if necessary, you may want to extract something from the response and use it later. So this throughput controller here is actually the magic that allows us to split the traffic. So in here, we have like 50% of the traffic getting that path details. And finally, CSV dataset config is what allows us to import data from your CSV file. And JMeter also provides lots of different types of assertions, like duration or response code assertions, and HTML or even code-based assertions. So let's have a look of like what a real test case can look like. First, you can see those are the helper method we defined before. And in the first throughput controller, we have like 50% of people creating paths. And then later, we extract ID from the response. And in the nested throughput controller, we have 85% of traffic get path details using the ID we just extracted. And this run test method is to grab the test configurations from the command and run test based on those configurations. So next, we're going to look at how we write our own commands line 2 to run the tests. We're using option parser. It is a class for command line options. So here, we add an option called duration to allow us to set test duration in seconds. And next, we just do command equal to the first argument you pass in, test equal to the second argument you pass in, and test response equal to the result of the calling that run test method I was showing earlier. Then we define what the command JMX and JMeter would do. If it's JMX, we just simply create the test plan. If it's JMeter, we would run the test and get result and logs. Finally, we just call the corresponding method depending on what command we get. So the result is just easy as JMeter or JMX, and your test name and the optional duration you can pass in. So it's demo time. This is not going to be a live demo because I don't really trust the demo god. Okay, so first let's look at what the command JMX will do. As you can see, it created test plans, like with all the like ramp up time, how many users we want, on test durations, and also throughput controllers. Then let's have a look at the JMeter command. You can see the yellow test says test executing locally, which means it's running the JMeter test plan in a non-GUI mode. Okay, so we have logs and test results being generated. And so we would want to see some like nice testing report, right? So this command here will generate, will process the test result and generate an HTML file that contains some graph views. So you can just have a look of the index, the HTML page, and see it in the browser. So as you can see here, we have a request summary graph showing all the success and failed requests, and a statistic table showing all the key metrics, like your throughput rate or response time. And we're also able to see some more detailed graphs as well, like response time over time, hits per second. Cool. So you may have noticed that where we're running the test in the non-GUI mode, we're just kind of like sitting there and knowing nothing, right? Not knowing what's happening. What if we want to see some real-time data? There's another open source tool called Taurus, created by BlazeMeter, that allows us to do so. So this command here, bzt, will initiate JMeter and run the JMX file. After a few seconds, we're able to see a dashboard with all the Taurus reports in real time. We're not just waiting for data coming in. Yeah, as you can see, you can see the failed and success request and response time, response code, everything. So after the test finished running, we're able to see the test results in the terminal. Cool. So next, I want to show you how to run the test plan using JMeter dashboard. First, we want to import the test plan. Yeah, as you can see here, JMeter is able to read the XML file and creating the test plan as we want it, like the test HTTP request and even the rejects we're using to extract the ID. Yeah. So now we're running the test, and while we're running the test, we're able to see some response and request data for each single endpoint. Okay, we're also able to see another statistic table showing all the KPI about the test and the graph of response time. Cool, so the result. We would want to check our APM or application performance monitoring tools to get the test result and see whether each of these criteria here, each of these fields here match the criteria we set before. So here is an example result of our test run. As you can see here, we've seen a big spike of error happening at the beginning. And there's one single point that get pad reviews has much higher response time and error rate than all the other endpoints. So we investigate further and found that this single endpoint has a really long query. So we will kind of have some N+1 query problem here. After we know what our problem is, we can do something about it. So what's our next step? Before I go into any details, I want to bring up this three-dimensional scaling model. The y-axis here, scaled by splitting different things, means we can split up your application into smaller pieces so that they can be managed and scaled independently. X-axis, scaled by cloning, which means you can increase the number of your database replications or use some horizontal or vertical autoscalers. And that access scaled by splitting similar things. For example, we can direct requests to different clusters based on certain criteria. So what we could do, we can distribute the traffic into, say, different countries. We can fine-tune our resource allocations, for example, your AWS instance type, your memory and CPU request limit. We can also improve the code base by using like a gem that can help reduce the number of queries, or maybe you want to add maybe another layer of cache. Oops, sorry. We also want to translate results into stories that stakeholders can understand. Also, we may want to run performance tests periodically to keep on top of it. So what's our learnings here? It's better to run baseline tests first in order to know your benchmarks. Also, beware of any test and production environment differences, because there are smaller pieces you may miss. We want to gather enough information to ask the right questions so that we make sure our performance test serves the stakeholders' purpose. Also, beware of caching, auto-scaling, and load balancing mechanisms, as the test result can be really different. Beware of the third-party dependencies. So if you're gonna hit your third-party API really hard, you better mock them, otherwise you may get really limited. Finally, expect surprises, because you may find bottlenecks somewhere you've never expected. So here are some resources. If you're interested, you can go to their flat.io Ruby JMeter repo for more information of that gem. And if you're interested to see the framework I was demoing before, go to my GitHub repo performance test Ruby JMeter. So if you may still remember the testing result of Nancy's public skill, I guess error rate and memory usage are within normal range thanks to my speaker notes. And CPU usage was a little bit overloaded as my heartbeat was so extremely quick. And yeah, since all of my key functionalities are still working as expected, I say I passed the exam, the test. Thank you.